In the oil and gas industry, accurate measurement is crucial at every stage of the supply chain, from upstream to midstream and downstream. Properly measuring each transaction ensures the interests of all parties involved are protected. Therefore, it is important to carefully select the right valves for these measurement applications to ensure accuracy. The correct choice of valve can have a significant impact on the reliability and precision of the measurements taken. Inaccuracies in metering can be caused by various factors, including turbulence in the flow, limitations in the range of the meter, the need for periodic calibration and repair, and the need for replacement of the meter. These factors can all contribute to errors in measurement, and it is important to carefully consider them when selecting the appropriate metering valves and procedures. Turbulence in the flow can significantly affect the accuracy of metering measurements. Therefore, it is important to take steps to minimize turbulence when selecting and installing metering equipment. Through conduit valve shall be selected. These valves allow the fluid to flow straight through the valve port, reducing the risk of turbulence that can affect the accuracy of the measurement. Number 1. Valve feature required is through conduit. It is important to keep a meter within its range of operation. Connecting meters in parallel and switching valves on and off frequently can help to accomplish this. However, doing so may cause seals to wear out rapidly, so it is important for those seals to operate without friction. Additionally, the low differential pressure across the closed valve requires that the valve be mechanical energized sealing. Sealing relays on differential pressure will not work. Number 2. Valve feature required is friction-free movement for seals. Number 3. Valve feature required is mechanical energized seal. Periodically calibration of metering equipment might be required by law in many cases. This is a typical online calibration layout. To ensure the same flow passes through both the prover and the meter to be calibrated, all valves shut down in this schematic diagram need to provide positive isolation with proven zero leakage. This is essential for ensuring the accuracy and reliability of the calibration process. It means that these valves must meet DBB to provide proven isolation under pressure from both sides of the valve in accordance with API 6D. Number 4. Valve feature required is DBB. Let's take the red meter an example. To repair or replace this meter, 3 valves must provide proven isolation so that the red meter can be removed from its position. For flammable or explosive flow, such isolation must be positive isolation with proven zero leakage. It means that valve must provide 2 sealings to meet DIB as per API 6D. Number 5. Valve feature required is DIB. If you want to select a metering valve that can fulfill your requirements, you need to consider all these features. Through conduit design, friction-free movement for seals, mechanical energized seal, DBB, DIB. Conventional trunnion ball valves may offer through conduit, double block and bleed DBB, and double isolation and bleed DIB features, but they are not generally suitable for metering applications. This is because they do not have mechanically energized seals, which means that they may leak under low differential pressure. Additionally, the seals in these valves may wear out quickly due to rubbing between the ball and seats. The rising stem ball valve is known for its powerful features, including friction-free movement of the seals and mechanically energized sealing. However, a single rising stem valve does not meet the requirements for double block and bleed DBB, or double isolation and bleed DIB, systems. The BridgeFlow ball valve is designed specifically to meet all requirements for metering applications. In the open position, the valve is through conduit, and the ball assembly rotates friction-free between the seats and sealing members to close the valve. When the stem is rotated further, the sealing members are mechanically pressed towards the seats, creating two mechanically energized seals that are effective regardless of the line pressure. As a result, the BridgeFlow ball valve meets both double block and bleed DBB, and double isolation and bleed DIB requirements. To open the BridgeFlow ball valve, the sealing members retract first. Then, the ball assembly rotates friction-free to the fully open position. This next-generation mechanical seal ball valve technology is patented in Canada, the USA, China, and is patent pending in the EU and Japan. For a demonstration of our prototype and to discuss how we might work with your firm, please contact with us.